to flip over the bottom trace, you need to flip over the bottom trace as we'll be flipping over the PCB. I've also flipped over the drills file because I'll be drilling last, and that'll be from the bottom side. And lastly, I've created my alignment holes, which will be used to screw those M2 screws in as pins. For the top and bottom PCBs, I've set the width that the V-bit is going to cut to 0.2 millimeters, set the number of passes to 2, and I've chosen combined passes. And for the G-code, I'm cutting down to a depth of only 0.1 of a millimeter. This is the V-bit just scratching the top of the surface. I'll be traveling 1 millimeter above the PCB, so this is where it's not cutting, it's just moving above. I've set the feed rate to 120 millimeters per minute. That's only 2 millimeters per second, so that's how fast it's going to scratch away the top surface of the PCB. And finally, I've set the tool diameter here to 0.2 millimeters. And for the drills, we'll be drilling down to a depth of 2 millimeters, travel speed 1 millimeter above the copper cladding. And for the feed rate, so this is how fast the drill's going to move. I've set it quite slowly here, only 15 millimeters per minute, which is only a quarter of a millimeter per second. And I've chosen that because I'm worried that that really tiny 0.3 millimeter drill bit will snap if I move any faster than this. So I'll be drilling the holes quite slowly, but I don't want the entire operation to move at this speed. So we'll be going into the G-code shortly after this to modify it so it's faster for every other operation except for plunging. So this is one limitation of FlatCam. It only gives you one speed to select for all of the moves.
EVE Online is a vast universe, alive with the unrelenting activity and combined history of its players. Pursuing lives of adventure, warfare, and prosperity, they share this existence in the biggest single shard, free.
And the final operation will be the board cutout. For the cutout, I'll be cutting down to a depth of 1.8 millimeters. The travel distance will be 1 millimeter above the copper. For the feed rate, I'll be moving quite slowly again for this operation. I don't want to snap the burr cutter I'll be using. So we'll be traveling at only 60 millimeters per minute, which is equivalent to 1 millimeter per second. The tool diameter, I'll be using a 1.5 millimeter burr cutter here. And finally, I've chosen multiple depth meters. So 0.3 into 1.8, it'll take 6 passes to fully cut down this PCB. And here are our exported G-code files from FlatCam. As you can see, there are 6 files, and we'll need to send them in one at a time because with each file, we'll have to change the drill bit that is attached to the Dremel on the 3D printer. We'll start with the alignment. That'll drill the 4 alignment holes for the screws to act as pins. Then we'll send in the top PCB G-code, so that'll mill out the top PCB trace. Then we'll flip over the board, followed by the bottom PCB traces. Then we'll drill the vias using the 0.3 millimeter drill bit. Then we'll drill the holes using the 0.9 millimeter drill bit. And finally, we'll send in the board cutout using our 1.0 burr cutter. That'll cut out our board and free it from the rest of the copper cladding. As we'll be using the Marlin firmware on our 3D printer, we just need to open up these G-code files and modify just a couple of things to make it compatible with Marlin. I'll start with the alignment holes G-code file. The first thing that we need to add to this file is this command here, M211S0. That disables the software end stops in Marlin and allows us to go into the negative territory. So for the alignment holes, I'll be using the M2 by 6 millimeter screws. I want to drill down to a depth of 6 millimeters here. And I've also just changed the speeds. So all the speeds have this letter F in front of them. So for the very first speed, I'm setting it quite fast for this, 300 millimeters per minute. It's only 5 millimeters per second. That's fast enough for what we need. That's going to move from the home position to the very first position that it's going to drill, followed by changing the speed right down to 15 millimeters per minute. It's only a quarter of a millimeter per second to drill that 6 millimeter hole. Then finally, once it's drilled the hole, I'm going to speed back up again to 300 millimeters per minute. It's going to move to the next coordinate, then slow right down to drill the next hole. So that's going to speed up the entire drilling process without breaking the bit attached to the Dremel on the 3D printer. The same changes need to be applied to the two other holes files, so the 0.3 millimeter and the 0.9 millimeter. But for the rest of the files that are left, so the bottom, top and the board cutout, you need to still open them up. You need to add the M211S0 command. And lastly, you'll notice when you open them up, this speed command, which starts with the letter F, is on its own. There's no G code in front of it. Marlin does not like that. It needs a G code in front. Just add a G0 to the start of that F command, and that'll ensure that the speed is applied correctly. As we'll be using a V-bit to engrave our PCB design, it is imperative that the platform is perfectly flat and level in respect to the V-cutter on the end of the Dremel. So you'll need to use your adjustment screws on each side of the bed to ensure the bed is level, left to right and front to back. And we'll also be homing the Z-axis using the tip of the bit onto the copper cladding. So I have these two alligator clips here. These are just connected to the Arduino board